last week, some of our lessons dealt with inverses. In particular, we worked with the inverses of the trig functions. Today we're going to go a step farther with that and look at the derivatives of the inverse trig functions. It's a mouthful, folks. First of all, we need to look at the 3 derivative rules. I've got them written out here. This is 6.8a in our textbook. You'll notice the derivative of the inverse sine and the inverse cosine are very similar. One has a negative, one doesn't, and then there's your derivative of the inverse tan. These assume that we're working straightforward problems. Now, if you would look at our examples, you'll notice we're not going to see a plain old x right here in our problems. What that means is we have to do the chain rule. Let's tackle this one. First of all, look at the rule. It says we do 1 over. I'm going to start out for my derivative, 1 over the square root of 1 minus. This says x squared because that's an x. When it comes to chain rule, this quantity goes in there squared. We're not quite done yet, because since it's a chain rule derivative, we need to do the derivative of 5x, which is 5. We can leave it like that. Let's go over to this one. Let's find the derivative. Well, I'll notice there's my rule. Negative 1 over the square root of 1 minus. What's playing the role of my x is this quantity x cubed, and it gets squared. Now to finish by multiplying by the derivative of our quantity, which is going to be 3x squared. Down to here. Derivative of the inverse tan of this quantity. We go 1 over again. There's no square root. Whatever our quantity is gets squared. 12x to the 7th squared. And to conclude, our derivative of the quantity, I'm going to apply a power rule. 12 times 7 is 84x to the 6th. One more here. Derivative 1 over the square root of 1 minus. Insert that quantity there, which is natural log of x. It gets squared. And finish with the derivative of your quantity, 1 over x. I would want to note that these are not product rule problems because you're finding sine inverse of something. Sine inverse by itself is meaningless. It needs to be of something to complete the function. All right, good luck.